Okay, one of the problems doing this stuff real time, which this is real time, sometimes you reach a conclusion that subsequent data says, no, you were wrong. About a week ago, we thought because we didn't have high gas pressures in the 3 ORW, the observation relief wells we'd installed, we thought that was a good thing. We didn't have a lot of gas pressure in the formation. I'm here tonight to tell you I was wrong on that, because what we found out subsequent to that, all the perforations in those wells are clogged up. So we were reading low pressure, but it didn't mean anything because the perforations were clogged up. So that's one of the things that was not correct. Now the next question is, how high are the pressures? I can't answer that until we get wells with open perforations. We're working on it, and I'm going to tell you how we're going to develop these wells now. Chris, you'll put up the Packer picture also. What we're going to do, and if you've been around the oil patch, this is standard technology. The perforations are just holes about the size of the end of my thumb, and you go down with what's called a perf gun, and it shoots a little bullet through the casing. What's happened here is we've got so much of this gray sticky clay, it's plugged up the perforations. And so we're out there trying to get gas out, but the perforations are clogged. So what you do, we're going in with a swab workover rig, and we're going to lower the Packer. And the Packer is here. This is what the Packer looks like. And what the Packer does, this black part, no, that's okay. The black part is actually a very strong piece of Kevlar reinforced rubber, and you inflate that and it seals off the well casing. And that's what we're showing here. We then have, that is attached to a tubing string, which we lower down through our control head, and we inflate the Packer, and it's kind of a super duper balloon. We actually inflate it with water because that's safer. We inflate it, that seals off the perforations, and then we go in with a swab. Everybody, what's a swab? Well, a swab is kind of a toilet plunger for gas wells, okay? What it does, you lower it down the inside tubing, and then you pull it back really fast, and creates a huge suction down there, and it opens up the perforations. And so that's what we're going to be doing on the 3 ORW wells that were installed. The key thing on all this, we know we've got gas pressure. Our early readings, we know now we're wrong. We know we've got gas pressure from some other stuff because you got bubbles coming up all over the place. You got bubbles coming up, everybody can see them. That means you do have some pressure. We don't know how high it is. So all this we're doing through a control head. So if something goes wrong, we can close everything off and seal the well up, and then you can go in and do what's called kill the well, which means you usually pump it through with heavy fluid to kill it. And somebody in here is saying, well, that's what BP tried. The big difference between this and the BP spill, where they had real problems with their control head, first of all, we're dealing with pressures that are much lower. We're probably looking at around 50 psi. The BP well was around 10,000 psi. In addition, our control head is much simpler. If we do get gas flow, all we have to do is close the valve. And that's what the big black thing, almost everybody here has probably seen the wells, that's what the big black thing is on top of the well. That's the control valve. So all we have to do when gas starts flowing is close the valve. The equipment's moving in. The Packer is on the truck coming this direction. In terms of sequencing, we're going to install the new ORW4 well, clean it out, get it perfed. If we have to go in and swab it, the Packer is going to be here so we can swab it and clean it out, and then we'll work on the other ones. Okay, that's what we're doing with the ORW wells. The next thing is the sinkhole. The sinkhole On the right is a 3D perspective of the sinkhole. This data was collected by Texas Brine Engineering Company. It's based on sonar data. They bounce sonar waves off the bottom. We took those, and you can interpret those as what the whole sinkhole looks like. And that's what you're seeing on the right. The sinkhole is about 450 feet deep at the deepest part. The data I'm talking about here was collected the 4th of October. We know, not from direct measurements, but from the roads and everything else, the sinkhole area of water, anyway, is expanding to the west. Now, it's a gradual expansion. It's not sudden, but there is settlement going on to the west. Our field operations people have noted that in the roads. I've been out there. I've looked at it. So it's slowly settling. It's not going to be a catastrophic thing, but it is slowly settling going to the west.
How do they know?
We've also collected water samples out of the sinkhole. The total dissolved solids, that tells you how much salt is in your water. At the surface, the total dissolved salt is about 4,000 milligrams per liter. That's background for the aquifer here. As we get down to about 100 feet, 100 feet was as deep as they could go with their equipment they had. The total dissolved solids gets up to about 72,000 milligrams per liter. We feel this increase in total dissolved solids is related to brine released during the cavern collapse. And when I get to that piece, I'm going to explain how we think that happened. On the far right, you'll see the total dissolved solids with depth. And our on the far right, you see the points plotted in red. If you project that down to about 300 feet, that's where we would encounter brine level of total dissolved solids in the sinkhole. Now that is an extrapolation, but the trend line in the last 3 samples, you can see for yourself, it's right up there. The basic data on the sinkhole, it's about 5.5 acres as of the 1st of October. We are getting gradual subsidence to the west, on the west side of the sinkhole. In going around, we've noticed bubbles that are in the swamp as well as in the bayous. You can go out and see them in the swamp when you get back in the trees. The last thing I'd like to say, and I think everybody here has probably seen it, on YouTube are all kinds of videos now of bubbles coming up in the sinkhole. That started a few days ago. The videos have been posted. People have looked at it. I view that as probably a positive thing from a pressure control standpoint. What that means, and in the next couple slides, I'm going to explain how all this fits together. It means the gas that's coming in from the formations at depth now has a direct pathway to the surface. It's not having to spread out and come out in the bayous and stuff. It can now come up in the sinkhole. So from a gas pressure standpoint, I view increased bubbling in the sinkhole as a positive thing with regard to buildup of gas pressure.